Need extra money for college? ISL Education Lending Scholarship Program provides $1,000 for college expenses. Registration is easy and no essay is required. Visit www.iowastudentloan.org/register to learn more. The scholarship is open to Iowa residents who are in high school and college students, as well as parents of those students. Register by November 30th for your chance at one of the 45 awards at www.iowastudentloan.org/register.
Discover unbeatable deals and convenience at your neighborhood family fare supermarkets. Score exclusive deals, earn rewards, join clubs, and clip digital coupons for extra savings all in one place. Our exclusive offers bring savings straight to your card. Explore a wide range of local products that support your community. With easy pickup and delivery options, saving time and grocery shopping has never been easier. Family Fare is all about making your grocery experience easy and affordable at your one-stop shop for all your grocery needs. Family Fare in your neighborhood.
This is SpaceTime Series 24, Episode 32, for broadcast on the 24th of March, 2021. Coming up on SpaceTime, the discovery of fast radio bursts dating back 10 billion years, have astronomers discovered hypothetical boson stars, and NASA's new moon rocket passes a major milestone. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have detected three of the most distant fast radio bursts ever observed. The three bursts, reported in the astrophysical journal Letters, each have redshifts greater than 3. That means they're each more than 10 billion years old, dating them back to a time when the universe itself was still in its youth. Fast radio bursts are sudden ephemeral flashes of extreme energy, lasting just a few thousandths of a second. But the amount of power released in that time is fantastic. In fact, the average fast radio burst releases as much energy in a millisecond as the sun generates in 3 days. Most fast radio bursts are singular events, never occurring in the same place twice. But of late there have been several so-called repeaters, that is, fast radio bursts which do reoccur at the same location. Now, a fast radio burst only ever occurring once at any location means they're likely to be caused by a cataclysmic event such as supernovae. But fast radio bursts occurring at the same location more than once means one of two things. Either there are two different sources which generate fast radio bursts, or they're caused by something other than a cataclysmic event. While their origins remain a mystery, there is a growing line of evidence linking them to a type of highly magnetized neutron star called a magnetar. Because of their cosmological origins, these three newly discovered fast radio bursts have the potential to provide fresh insights into a range of astrophysical problems. Scientists found the three fast radio burst events using China's 500-meter aperture spherical radio telescope, FAST. The study's lead author, Nu Shinui, says the newly discovered events, combined with the first fast radio burst detected by the FAST telescope last year, suggested there could be as many as 120,000 of these events arriving on Earth every day. This is SpaceTime. Still to come, have astronomers discovered hypothetical boson stars, and NASA's new moon rocket passes a major milestone. All that and more coming up on SpaceTime. A team of scientists are claiming that the heaviest black hole collision ever observed may be something even more mysterious, the merger of two so-called boson stars. A report in the journal Physical Review Letters claims the event, which produced the gravitational wave GW 190521, could be the first evidence for the existence of these hypothetical objects, which are one of the candidates for dark matter, a mysterious invisible substance that makes up most of the mass of the universe. Scientists have no idea what dark matter is, but they know it exists because they can see its gravitational influence on galaxies. Since 2015, the two LIGO detectors in the United States and the Virgo detector in Italy have detected more than 50 gravitational wave signals. Gravitational waves are ripples in the very fabric of space-time. They're generated by some of the most violent events in the universe, such as the merging of superdense objects like neutron stars and black holes. However, the promise of gravitational wave research goes much deeper than this, maybe even providing evidence for previously unobserved and even unexpected objects, in the process shedding new light on mysteries like dark matter. The GW 1905-21 gravitational wave signal, which was detected in September 2020, was consistent with the collision of two stellar mass black holes of roughly 85 and 66 times the mass of our Sun. The merger resulted in the production of a new black hole of some 142 solar masses. And that's significant because it's the first of a new previously unobserved category of intermediate-sized black holes. So the discovery is of paramount importance because intermediate-sized black holes are a missing link between the other two well-known types of black hole families. There are stellar mass black holes, which form from the collapse of stars, and supermassive black holes, which reside at the centres of most, if not all, galaxies. But one of the challenges presented by this particular gravitational wave event was justifying how the heaviest of the two colliding black holes, that's the one with 85 solar masses, could have formed out of the collapse of a star at the end of its life. See, even the bigger stars should have shedded off much of their mass by the time they collapse as supernovae, and 85 solar masses really stretches those calculations. So instead, the authors suggest an alternative explanation, one involving the collision of two exotic hypothetical objects called Boson Stars. Boson stars are one of the many candidates to try and explain dark matter. Unlike the electrons, neutrinos and quarks which make up particles of matter, bosons are particles of force, which therefore have masses billions of times less than electrons. In fact, some bosons, such as photons, have no mass at all. The authors compared the GW 1905-21 signal to computer simulations of boson star mergers, finding that boson stars would explain the data slightly better than the analysis conducted by LIGO and Virgo. Now, if they're right, and that's a big if at this stage, the new findings suggest that because boson star mergers would be much weaker, the event, the collision, would have been much closer, and it would have involved a much larger mass for the final black hole, something around 250 solar masses. If they exist, boson stars would be almost as compact as black holes. But unlike black holes, they don't have an event horizon, point of no return. It's an intriguing idea. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
We are going to now look at this research, this rather strange issue surrounding large gravitational wave detection, because there's a possibility, according to this latest data, that these gravitational waves are telling us fibs. They're not actually indicating what we thought they were indicating, or not all of them, or maybe none of them. Who knows? What's going on?
So it's not all of them. I mean, most gravitational wave detections of things like colliding black holes and colliding neutron stars, I think they're secure. I think they're so well modelled that they fit the bill exactly, and they fit all our understanding of what black holes might be like and what constitutes a black hole. I think, generally speaking, gravitational wave astronomy is in good shape, and we're discovering things fairly regularly. However, one in particular has raised some questions, and it's all about the mass of the objects that we think are involved. So this is a gravitational wave signal that occurred on the 21st of May 2019, and it comes from a distance of 7 billion light years away. It's, this is really in the depths of the universe. That's so we're looking back more than half the age of the universe when you look back 7 billion light years. And so it was a massive collision, and the detectors gave a very strong signal. You'll remember that what happens when black holes collide is that they approach each other. They're basically in orbit around one another, and that orbit spirals inwards as they eventually coalesce. And it's the spiraling inwards that gives you this characteristic chirp in the gravitational wave signal. With I've got to do it, haven't I? That's the way it goes. And where you get to the end, that's when the two have coalesced, and essentially they've formed a black hole which no longer gives a gravitational wave signal because it's not being accelerated. That's the whole point. So this event in 2019, the calculation and the analysis of that signal let the astronomers determine what size of objects we're talking about here. And it was 2 black holes, one at 66 solar masses and one at 85 solar masses, 85 times the mass of the Sun. And the reason why this is now in the news is that there's been a reanalysis, more of a different interpretation of what these black holes might have been. And it's an international team of very notable astrophysicists. So the suggestion is that these were not actually black holes, but theoretical objects, which are called boson stars.
Wow.
And now bosons are the subatomic particles that carry force, like the Higgs boson. That's the thing that gives us the mass. The photons are actually bosons, the subatomic particles that are transmitting you and me around the universe at the moment by, electromagnetism. So I have not come across boson stars before, I have to say, and this interested me greatly because it could be a new form of matter. But the astrophysicists involved believe that some of the, if you do have boson stars, what they could be made of would be something that is the same stuff as dark matter, whatever it is that's invisible in the universe, that's holding galaxies together and holding galaxy clusters together.
Yeah, you took the words right out of my mouth there. I was going to walk that path. I was going to bring up the dark matter question. Well, if I didn't, somebody in the audience would have. If that's the case, it could answer a lot of questions, could it not?
Yes, if it exists, I suspect it's going to raise more questions than it answers, though. But you're right. So what comes out of this is a black hole with a mass of 142 times the sun's mass. And that's getting on for what we call an intermediate mass black hole, which is where there's a gap. There's a sort of gap in the black hole range between the stellar mass ones and the supermassive ones. And there's not much in between. There have been a few candidates, but it's not much. And so 142 times the mass of the sun is getting on that way. But the reason why this work has cast doubt on whether it's black holes or not is that a black hole of 85 solar masses shouldn't exist. Because if you're assuming that the 2 candidate black holes, the 2 that collided, if, as we believe most of these small black holes do, if they come from the detonation of a single star at the end of its life, a supernova explosion, there is a limit on how big a supernova explosion you can have that will form a black hole. And if you've got one over about 65 solar masses, a single star of that actually much higher mass to start with because it's blown away a lot of its outer material, but something over 65 solar masses, it can't collapse to a black hole. And it's because, and I'm not a supernova expert, but I've heard of these things. They are called pair instability supernovae. A star in that mass range over 65 solar masses, it produces a pair instability supernova. And what it does is completely obliterates the center of the star, the core of the star, which is what in a normal supernova explosion, that's what collapses to the black hole, is the core of the star. But apparently in a pair instability supernova, the whole thing's blasted to pieces. So you don't get anything left behind. And so you shouldn't be able to find black holes more than 65 solar masses. And here is one that is being postulated as an 85 solar mass black hole. Now, it is possible that that black hole got to its size by merging with another one. So it might have been 2 stellar mass black holes that merged and formed one of 85 solar masses. But the other thing is that, and it comes from Spanish researchers actually, Juan Calderón Bustillo of the Galician Institute of High Energy Physics in Spain. They've looked at this possibility of these boson stars, and they say that it would match the numbers. One of the other astronomers, José Font, I love this, University of Valencia in Spain, he says, our results show that the 2 scenarios are almost indistinguishable given the data, although the exotic boson star hypothesis is slightly preferred. What he means by the 2 scenarios is the pair of black holes or the pair of boson stars. And the theoretical look at these boson stars actually is slightly preserved. He goes on to say, this is very exciting since our boson star model is, as of now, very limited and subject to major improvements. In other words, we don't really know what they're dealing with here. A more evolved model, that means with all more fancy bells and whistles on the theoretical model, a more evolved model may lead to even larger evidence for this scenario and would also allow us to study previous gravitational wave observations under the boson star assumption.
Fascinating.
It is.
And I come across a description of what a boson star might look like, and they basically are suggesting they'll look a lot like a black hole except for one thing, and that is that they don't have an absorbing surface. That would stop photons or an event horizon. So they would actually appear totally transparent, which is it's mind-boggling. Yeah. And they go on to say they're basically compact blobs of Bose-Einstein condensate in space.
So which is really interesting. And that kind of makes a bit more sense of it, because a Bose-Einstein condensate is basically matter that is sort of compressed to a level where it behaves like a single quantum object. And quantum objects are weird, and we usually think of them as being tiny, microscopic scale objects. But here's a star that might be a single quantum object, which raises all kinds of possibilities, because quantum objects can be in two places at the same time. And maybe these Bose-Einstein condensates could be as well. It's great stuff.
There's now the answer to long-haul space travel in no time.
Yeah, that's right. Yeah. Find yourself a friendly boson star and hook yourself to it, and there it goes.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. Still to come, NASA's new moon rocket passes a major milestone, and later in the science report, why some otherwise healthy people develop life-threatening COVID-19 symptoms. All that and more still to come on Space Time.
Woodhouse Chrysler Dodge Jeep Ram is bringing you more power, capability, and savings with the full lineup of new Ram trucks during the Black Friday sales event going on all month long. Lease a 2024 Ram 1500 Crew Cab Bighorn for $429 per month. Visit our 2 convenient metro locations in Blair or Bellevue, or online anytime. Lease for 42 months, 10,000 miles per year with approved credit. Tax, title, license extra. $2,500 down plus first payment and $299 doc fee due at signing. Example stock number BC230242. Offer expires 11/30/2023. See dealer for details.
NASA has just completed a successful test firing of the core stage of its new SLS Moon rocket. The 8-minute, 19-second hot-fire main engine burn in the B-2 test stand at the Stennis Space Center in Mississippi is a crucial milestone ahead of the Artemis I mission slated for November. Artemis I will carry an unmanned Orion spacecraft on a test flight to the Moon and back in preparation for future manned lunar missions. The test involved igniting all 4 Aerojet Rocketdyne RS-25 main engines and maintaining the complete flight profile from liftoff to main engine cutout.
SLS, red line back there. H-buoys on.
Go for engine start.
H-buoys are on and engine starts has been okay.
And all personnel, we've got engine start and we're into the plus count. All personnel, please continue to monitor your systems, and grass is in control. Plus 60 seconds starting TBC profile number 1. Again, personnel, we've got a fire indicated. Everyone go ahead and ATS. ATS. And copy, you want me to hold down ATS? I copy that. You cancel it out. 2 plus 8 minutes. And then the TBC profile number 2.
All right, so we're just over 8 minutes into the plus count.
Well, personnel, we're coming up hopefully on a lock depletion here, and we have a cutoff. All right. REA, can you verify? REA and channel 16, verify. Safe engine shutdown, please.
Safe engine shutdown.
And you're in post shutdown standby, correct?
Correct.
NASA will use this test data to help validate the SLS core stage design for flight. The SLS, short for Space Launch System, is the biggest and most powerful rocket ever built, surpassing even the mighty Saturn V Apollo moon rocket. It'll be used to launch NASA's new Orion spacecraft, which is being developed to transport crews beyond Earth orbit to the Moon and eventually onto Mars. The hot fire test saw the former Space Shuttle main engines, which are used to power the first stage of the SLS, generate more than 1.6 million pounds of thrust within 7 seconds. The program included gimbaling the engines, that is, moving them in specific patterns to direct thrust, powering the engines up to 109% of their rated power, as well as throttling down and back up again, just as they will do during the actual ascent to orbit. The first attempt to test these engines back in January this year resulted in an early shutdown, just 67 seconds after ignition. That was put down to overly conservative test commit criteria on the thrust vector control system, a specification specific only for ground testing, not for flight. In fact, had that scenario occurred during flight, the rocket would have continued to fly normally. Okay, so with the crucial hot fire engine test out of the way, what comes next? Well, the SLS core stage will have its engines attached to it, and it will then be shipped to NASA's giant vehicle assembly building at the Kennedy Space Center in Florida. Once there, it'll be mounted vertically on its mobile launcher. The upper stage, as well as the Orion spacecraft and the massive strap-on solid rocket boosters, another legacy from the space shuttle, will all be attached in preparation for the Artemis I flight. This is SpaceTime.
Woodhouse Chrysler Dodge Jeep Ram is bringing you more power, capability, and savings with the full lineup of new Ram trucks during the Black Friday sales event going on all month long. Lease a 2024 Ram 1500 Crew Cab Bighorn for $429 per month. Visit our 2 convenient metro locations in Blair or Bellevue or online anytime. Lease for 42 months, 10,000 miles per year with approved credit. Tax, title, license extra. $2,500 down plus first payment and $299 doc fee to its signing. Example stock number BC230242. Offer expires 11/30/2023. See dealer for details.
And time now to take another brief look at some of the other stories making news in science this week with the Science Report. 2 new studies have identified why some otherwise healthy people go on to develop life-threatening COVID-19 symptoms. The studies, reported in the journal Science, show that these severe symptoms can develop in people lacking type 1 interferon, a set of 17 proteins crucial for protecting cells and the body from viruses. One study found that 1 in 10 people with life-threatening COVID-19 pneumonia, mostly males, produce antibodies which target and neutralize their own type 1 interferon. That may explain why some men are more likely to develop a severe form of the disease. The second study found a group of people who carry a specific genetic mutation which stops their own immune systems from producing type 1 interferons in response to SARS-CoV-2. In both cases, the lack of type 1 interferon appears to be a common theme among a group of COVID-19 sufferers whose severe version of the disease has thus far been a mystery. Over 2.7 million people have now died from the COVID-19 virus, with another 121 million having been infected since the virus first emerged from Wuhan, China, and spread around the world. Neanderthal fossils discovered in a cave in Belgium and believed to belong to the last survivors of their species in Europe may be thousands of years older than previously thought. Earlier radiocarbon dating of the remains yielded an age of around 24,000 years, suggesting that was when Neanderthals died out in Europe. However, new testing reported in the Journal of the Proceedings of the National Academy of Sciences has pushed back that date to between 44,200 and 40,600 years ago. The new robust method still relies on carbon-14 dating, long considered the gold standard for archaeological dating. But it refines the way the specimens are collected to better exclude possible contamination. Facial recognition has been rapidly taking over Moscow since the start of the coronavirus pandemic, with authorities using it to enforce lockdowns and the general public using it for contactless payments. The biometric technology is now expanding right across Russia, with the nation's leading food retailer now rolling out the facial recognition payment system to 3,000 of its stores. The company says its survey showed that 70% of Russians support the so-called FacePay system. And even the Moscow Metro is getting on board. You can now buy your train tickets simply through facial recognition. However, the push is alarming human rights activists, who warn of creeping state surveillance by the Kremlin, with authorities known to abuse the system to illegally identify peaceful protesters who were later arrested. The Russian push for facial recognition follows its widespread adoption for public surveillance across China as part of its dystopian social credit score system, which is used to reward and punish citizens depending on their correct behaviour in the eyes of the Communist Party. The social credit score system determines what sort of accommodation people have, what sort of schools their kids can attend, what sort of healthcare is available to them, even what sort of transport they're allowed to use and when they're allowed to travel. And facial recognition is a key part of that system. Geologists have identified a new mineral called kernowite, It was discovered in an old specimen collected at a single location in Cornwall in the 1700s. Kerno is the Cornish word for Cornwall. The specimen became part of the London Natural History Museum's collection in 1964, but it's only now been identified as new to science. Kernowite is a secondary mineral, formed when other rocks close to the surface have their chemical elements mobilised by circulating water. The elements now present within the fluid recombine to create a new mineral from different elements of previously crystallised rock. A new mineral is determined by its chemical composition and the positions of the atoms within a 3D crystal structure. A report in the Mineralogical magazine describes Kernowite as unique because one part of its internal structure is dominated by iron instead of aluminum. The Therapeutic Goods Administration approves the new medical app for smartwatches, the World Wide Web turns 32, and Telstra hits 3,000 5G sites. With the details on these and other news from the world of technology, we're joined by Alex Sahara-Reutt from ITWire.com.
The Apple Watch in the US, in New Zealand, Hong Kong, Singapore, Korea, other places, has had the ability to do the ECG function of the Apple Watch 4, 5 and 6, and also to check for atrial fibrillation. And this feature has been unavailable in Australia, but the TGA, the Therapeutic Goods Administration, has finally given authorization for Apple to launch these features in Australia. So either in the next Watch OS update or in the one after that, probably in the next couple of months, this feature will now be available for Australians, and it has saved people's lives overseas. They've received a notification on their watch that they have an irregular heartbeat detected, then take that to your doctor and show them, and it has saved their lives.
32 years since the World Wide Web as we know it came about. Now, that's different from the internet, isn't it?
Yeah, the internet started off in the 60s to do with the military so that they could launch missiles should part of the network go down. And then in the 70s, universities got hold of it and started sending the first emails to each other. So we've had the internet itself for a long time, but it wasn't until 1989 that Sir Tim Berners-Lee came up with a concept at CERN, which was for a hypertext information system. And his boss at the time said, vague but interesting. And of course, 32 years later, the World Wide Web and all of the services that sit on top of that and that we take for granted today are now available. And in an open letter to the world, Sir Tim Berners-Lee was talking about how we need to make sure that enough of the world's people have access to the internet, that it remains free, that there are inexpensive devices that people can use. And he was also showcasing many of the different cool projects that people have created on top of the internet. And if you go to the webfoundation.org, you can read that open letter and see some of the projects and some of the young leaders that he was speaking about.
And of course, one of the things which has spurred on use of the World Wide Web has been improved communication, such as 5G. And Telstra, Australia's largest telecommunications company, now has over 3,000 5G sites.
That's right, yeah. There's a testing company called Umlaut, which drives cars across Australia and I think in other parts of the world. And they have come out saying that Telstra has scored top marks for their 5G coverage. That is 3,000 sites that have now been switched on. The closest competitor, Optus, has 1,000 sites and Vodafone only has a few hundred. So we're getting to more and more 5G across Australia and the world. 5G has now really started to blossom around the world. So many countries now have it. The price of 5G phones is falling lower and lower. The lowest price will be about $200 US for entry-level 5G phones. And it won't be long before every phone that comes onto the market will be 5G. And by June, July this year, Telstra will have 75% of the country covered with 5G. And so we're seeing these sorts of rollouts in other parts of the world. In the US, T-Mobile and Verizon and AT&T are all rapidly rolling out 5G. So 5G really is improving the way that people can access the internet, and even faster versions of 5G are coming. Optus in Australia was able to do carrier aggregation where they could merge two different bands of 5G together to get even faster 5G. They did the same sort of thing with 4G. So we're seeing lots and lots of improvement in this area. And of course, we spoke recently about how 6G is due in 2030. So the internet, the World Wide Web, your communication devices, they are just getting better with no end in sight.
One thing which does have an end in sight has been Apple's HomePod, the big HomePod. It's been discontinued. Why?
Once the HomePod minis came out, they probably saw the more expensive HomePod sales drop. So they've kept it going as long as they could. It's been 4 years since we've had the original HomePod. And, one thing that Apple doesn't have is devices like the Amazon Echo or the Google Nest Hub with a screen. I mean, Apple will get you to use your iPhone or iPad as the screen and then use the HomePod as speakers. So we might end up seeing some sort of HomePod with a screen in the future. But at the moment, HomePods have never been cheaper. With the HomePod Mini, they've been selling extremely well. And, Apple discontinues products, and this one has been discontinued.
Is it true you can get the home pods arguing with each other?
Look, I have seen some years ago there was people who had sort of tried to engineer conversations between one smart assistant and another. Sort of ask one question and you ask one assistant, which sort of asks another assistant, and I guess it's like a game of audio ping pong.
Yes.
But I mean, they weren't designed to talk to each other as such, at least not yet. But for now, it's just a bit of fun. They're not really meant to talk. And sometimes when you talk to one device, you call it by the wrong name. It sort of says, "Oh,
the other one
that's
answers.
not me. That's somebody else." It heralds the time when we will have those devices properly talking to each other, getting commands from other devices. You'll tell one device to tell your other devices to do things.
Alex, it's called Skynet.
Well, yes, that is also a worry. And I always say that science fiction movies, especially dystopian ones, are warnings to humanity to not let this happen. The big question is, will we heed those warnings? And will that sort of thing happen? We don't know, but hopefully not.
Judging by history, we won't heed the warnings. 1984 was never meant to be an instruction manual.
Well, that's correct. And, we have to be glad that we live today before any such Skynets exist.
Well, Mad Max was set in 2021.
Yes, and there was still plenty of fuel.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to SpaceTimeWithStuartGarry.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGarry on Twitter, @SpaceTimeWithStuartGarry on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.